Hey guys, sorry I couldn't be here with you today, but I wanted to go over the drill with you guys, and you've probably already noticed, if you did number one, that there was a slight typo. I think I fixed it on mine here, so you can see that it clearly says what is the value of t. On mine it says when y equals the square root of 2. I believe on yours it says when x is the square root of 2. That would obviously lead to a little bit of confusion for that part. And I don't remember if there was any other typos, but I think that was the only one that was in there. So let's go ahead and go over this the best that we can. Solving the equation in number 1 for t. Hopefully that wasn't too difficult. It's a two-step process. You would add 4 to both sides. So you would get having all kinds of little technical issues here. Let's see if we can fix that. So we should get adding 4 to both sides. Why is this not working? There we go. Y plus 4 equals 3t, and then solving for t you would divide both sides by 3. So you would get that t equals y plus 4 over 3. Okay, again, that really shouldn't have been too difficult. Now when it says what is the value of t when y equals the square root of 2, literally you're just going to plug the square root of 2 in for y, so we should get that t equals the square root of 2 plus 4 over 3. And there's really nothing else we can do there. We can't simplify that any further, with the exception of splitting the numerator over the denominator. Otherwise, the only way to simplify it any further would be to use a decimal approximation for the square root of 2, and we're not going to worry about that. That is the answer for number 1 that we'd be looking for. In number 2, solving for t. T is now inside of a parentheses, which means we need to isolate that parentheses first. So, want to solve for t in number 2, we're going to divide both sides by 3 first. We'll get x over 3 equals the quantity of t minus 4 squared. Then we'll take the square root on both sides. Now remember, when you take the square root on both sides here, because you are taking the square root on both sides of an equation, you must include the plus or minus. So it's x over 3 and then equals, whoops, running out of page there. Let's see if I can fix that. I'll just move that whole thing over, make it easier. Plus or minus square root of x over 3 equals t minus 4. And then solving for t, we would add 4 to both sides. Typically, you want to put the plus 4 out in front of the square root, only because if you happen to do this, and I am going to erase this, if you happen to do this, and you make your square root symbol a little bit too long, we don't know if that's underneath or outside of the square root symbol, so we don't really want to write it that way. If possible, we would just like to add the 4 like that, and that's t, and that of course would go up here where the t is. I just kind of ran out of room there. And then when t equals negative 4, so we have an issue. If I plug negative 4 in for t, I'm sorry, when x is negative 4, I apologize. When we plug negative 4 in for x, we're now trying to take the square root of a negative number, which we know in the real number system does not exist. So if you had said no solution, you would be correct. At least that is no solution in the real number system. If, however, we're using imaginaries, which is a possibility, then we would have solutions. We would actually have 2 solutions in this case. If we use imaginaries, we would have 4 plus or minus square root of negative 4 thirds, and that can be simplified because the negative under the square root comes out to the front as an I. So that would be 4 plus or minus I square root of 4 thirds. And we can even simplify that a little bit further in the fact that the square root of 4 thirds, the square root can be split on the top and the bottom, in which case we would have 4 bring this down here. So we'd have 4 plus or minus I, 2 on top, and then square root of 3 on the bottom, because we can't really simplify square root of 3. And then if you actually rationalize this, which is not necessarily required unless it says so, but if you rationalize that by multiplying the top and the bottom of that by the square root of 3, then you would get 4 plus or minus I, 2 square roots of 3 over 3. This would be if it was using imaginaries. If you had said no solution because there's no real number square root, that would be acceptable in this case as well. It's really just going to depend on what we're doing. Either way, you'd be okay. Number 3, finding the solution of the given equations. Y plus 4 equals 3x and y equals 5. This is a system of equations because simply it has 2 or more equations in it. In this case, we already know the solution to the y value is 5. It's given to us in the second part. Well, we can simply take 5 and plug it into y in the upper equation. So we'd get 5 plus 4 equals 3x, which means that 9 equals 3x. Dividing both sides by 3, we get the x value to be 3. So our solution is the ordered pair 3, 5. That just means that that is where these two equations cross on the graph at the point 3, 5. And then I believe that the last one here, number 4, is probably the easiest one. You're literally just going to find the location of the object traveling along this parametric equations. At 4 seconds, we're going to plug 4 in for t and see what we get out for x and y. So let's go ahead and do that. So x equals 4 times 4 plus 3. So x is going to be, what, 16 plus 3 is 19. And then y is going to be 1/2 of 4 minus 5. A half of 4 is 2, minus 5 is negative 3. So our solution is the ordered pair 19, negative 3. Again, that was probably the easiest one on there. Alright, so that is your drill. Hopefully if you guys have any questions on that still, you can come see me when I get back.